This chapter goes into quadratic equations. We've already done a little bit with quadratics back when we were working on factoring, and we solved some quadratic equations by factoring. Now we're going to start to look at what the graph of a quadratic equation looks like and how to solve it with the quadratic formula, and we'll get into quadratic inequalities as well towards the end of the unit. So we did some linear inequalities, but yes, there are quadratic inequalities as well. So we don't do every section in chapter 11. We do 11.1, 11.3, 11.5. So we'll start with chapter 11.1 and move on from there. So what is a quadratic equation? Probably a good time to review that. So a quadratic function can be written in this form. It's a second degree polynomial, so it's got a squared term, it's got an x term, and then it's got a constant. Now, all three of those pieces don't need to be there, but this first one has to be. If it doesn't have a squared term, then it's not a quadratic function. So that's why it says here that a, b, and c are constants, but a can't be 0. If a is 0, I don't have a quadratic function. I have a linear function. The domain of a quadratic function is all real numbers. So if you look at an ax squared plus bx plus c, there's nothing that's going to make that undefined. There's no negatives under square roots. There's no zeros on bottoms of fractions. But as long as that's the case, then the domain is all real numbers. The range will depend on the function itself. And we'll get into that a little bit more as we go on. So the question is, what do these things look like? The graph of a quadratic function is called a parabola. We might start by plotting a few points. So let's say we put in some values for x and y and see what this graph looks like. So we'll be kind of traditional. Let's put in -2, -1, 0, 1, and 2. When you square a negative, you get a positive. So when you square a -2, -2 squared is +4. -1 squared is +1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So now let's come over to the grid and work to graph that. So -2, 4 is up here, -1, 1, 0, 0, 1, 1, 2, 4. It turns out I can keep going, right? -3 squared is 9, +3 squared is 9. So we start to get the idea already that these things repeat, that putting in a -3 and putting in a +3 both give us the same y value back. When you graph this, not always perfect on a tablet, but when you graph it, you should end up with a function that's U-shaped. And so there is the beginnings of a parabola. We can identify a couple of properties of this parabola just by looking at it. One of them is that I can clearly see that the parabola opens upward. It turns out that it has to do with this number before the x squared, that a value. So in this case, a is 1, which is a positive number. So if it's a value that's greater than 0, then the parabola opens upward. The other thing I can identify is this vertex. Right there is the vertex. The vertex in this case is at the origin. That vertex also has another property to it, which is that it identifies the axis of symmetry. If I look at this axis down the middle here, right, which in this case is the y-axis, half of the graph is to the left, half of the graph is to the right, and they're mirror images of each other. So that axis that runs down the middle is the axis of symmetry, meaning that the graph is symmetric around that axis. Reflection symmetry maybe is a term that you've heard before. Most common second grade definition of symmetry. If you ever fold one of those hearts, you folded it in this half, and then you opened up the construction paper, and what happened? You got the other half of your heart, because that heart was symmetric across that line you folded it on. So the same thing happens with a parabola. If I had the ability to fold my screen, I could graph half of it, open it up, and the other half would be a mirror image across that axis of symmetry. Bet you they didn't make folding parabolas like that in the second grade. Missed opportunity. Parabolas can open upward or downward. They open upward when that number before the x squared is positive. They open downward when it's negative. And we'll get to see a couple of examples as we graph it. The vertex is the highest point if the parabola opens downward. So if the parabola opens downward, then the vertex is up on the top here. As we saw in the one we graphed before, if it opens upward, then it's the lowest point on the graph. And I talked about that vertical line that passes through the vertex is the axis of symmetry. So let's take a look at a couple of examples. These are already graphed for us, so the point isn't to graph these. The point is to identify vertex and axis of symmetry. So look at the first one. That's the one we just graphed. It's y equals x squared. It has a vertex at 0, 0. That red line is the y-axis. It's also the axis of symmetry. Notice the one to the right is a function that is upside down. At least it looks upside down to us. That's because whatever function this is, the number before the x squared is negative. It's also pushed up a couple of units. So the axis of symmetry is still the y-axis, has an intercept at 0, 2. That's the vertex. So in that case, the vertex is the highest point on the graph. Look at the third one. There's two things that are interesting about that one on the right. One of them is that the axis of symmetry is not the x or the y-axis, right? The axis of symmetry is this vertical line here at x equals 2. The other thing you'll notice is that the graph looks a little bit narrower than the first two. The first two look a little bit wider. That graph at the end looks a little bit narrower than the other two. And so it turns out that that a value in front not only tells us which way the graph opens, but it tells us how wide and how narrow that graph is. So that number before the x squared turns out that it covers a lot of ground. All right, so this one says use that graph to identify the vertex, axis of symmetry, and yes, whether it opens upward or downward. That should be the easiest question, right? So for the first one, obviously it opens upward. If we want the vertex, we're looking for the highest or the lowest point on the graph. So if you come down here, this point over here is the lowest point on the graph. It has an x-coordinate of -2, has a y-coordinate of -1. That's the vertex. The axis of symmetry goes through the vertex. So now if I'm looking for an axis of symmetry, if that axis of symmetry goes through the vertex, it has to have the same x-coordinate as the vertex does. So if the x value is -2, that is actually the equation of the line, x equals -2. So it makes it easy to identify the axis of symmetry. All you do is you look at the x-coordinate of the vertex, and it's x equals that number because it has to be a vertical line. Every x-coordinate has to be the same. All right, for part B, obviously that opens downward. I could see that. What's the vertex? In this case, because it opens downward, the vertex is the highest point. It's 0, 4. And because it's 0, 4, that must mean that x equals 0 is the axis of symmetry. So the vertex is 0, 4. X equals 0 is the axis of symmetry. X equals 0 is also known as the y-axis. Now, if you want to find the vertex, you can do that from the equation of the graph. Obviously, you could take the graph's equation, plot a few points, and look to see physically where on the graph the vertex is. But you can also find the vertex using the equation. And sometimes that's helpful when you go to graph it, because the vertex is not always at the origin or on the x or on the y-axis. It may be somewhere in the middle of the plane. So knowing the vertex will help you to graph a more accurate graph without having to search. So the way you do this is by looking at your a and b coordinates here, and the x-coordinate is -b over 2a. Once you've found that value, that -b over 2a, that's your x-coordinate. If you want the y value, you got to substitute it back into the function to find the y value. Okay, so -b over 2a is the x-coordinate. That's why this says the vertex is at -b over 2a, comma, f of -b over 2a. That means you're taking your -b over 2a, putting it in for x to find out what y is. Because remember, the vertex is a point. So it's going to have both an x-coordinate and a y-coordinate. So just having an x-coordinate isn't enough to identify an ordered pair. All right, this thing says find the vertex of the graph of f of x equals 2x squared plus 8x minus 3. So what is my a value and what is my b value? My a value is 2, my b value is 8. So the x-coordinate of the vertex is -b over 2a. So -8 over 2 times 2 gives me -8 over 4, gives me -2. So that's the x-coordinate. The y-coordinate is going to be the function evaluated at -2. So I'll get 2 times -2 squared plus 8 times -2 minus 3. So I'm putting that -2 into x for f of x. So -2 squared is 4. 4 times 2 is 8. Minus 16 minus 3. So 8 minus 16 is -8. Minus 3 is -11. So by my calculations, the vertex is -2, -11. All right, so how do I graph these things? Let's take a look at how to graph these parabolas. One way we can choose to do it is by finding the vertex and picking points on either side of the vertex. So here's f of x equals x squared minus 2. Now, a little trick here. Remember the function is f of x equals ax squared plus bx plus c. You notice here we have no middle term, which means b is 0. So if the coordinate is negative b over 2a and b is 0, then the x coordinate is just going to be 0. Right? So if you see one of these equations like this, x squared minus 2, where there's no x term, if there's no x term, then the x coordinate of the vertex is 0. In this case, then the y value would be negative 2. So my vertex is 0, negative 2. I can also tell the graph opens upward because the number in front of the x squared is 1, and 1 is a positive number. Okay, so if it's greater than 0, opens upward. Once we find that vertex, we usually pick a couple of points on either side of the vertex. Now, I know in this case, the couple of points are negative 2, negative 1, 0, 1, and 2. But if it had been, at x equals 3, then we would pick points on either side of 3, maybe 1, 2, 3, 4, 5. This way, we don't pick all points on one side and never get to see it turn. All right, so negative 2 squared is 4. 4 minus 2 is 2. So it goes to the point negative 2, 2. All right. If I put in a negative 1 squared is 1. 1 minus 2 is negative 1. So if it goes through negative 2, 2, it also goes through negative 1, negative 1. It goes through 0, negative 2. We already figured that out. 1 squared is 1 minus 2 is negative 1. So it goes through 1, negative 1. 2 squared is 4 minus 2 is 2. So it goes through 2, 2. If you kept going, if you put in, let's say, a 3, 3 squared is 9. 9 minus 2 is 7. So it goes to the point 3, 7. Meaning it also goes to the point negative 3, 7. And then we graph this. All right, if you ever want to have some fun with one of these graphs, it's a little trick that might help you to plot these things. If that a value is 1, right? So again, disclaimer, this works if the a value is 1. I went up 1 and over 1. Then I went up 1, 2, 3 and over 1. Then I went up 1, 2, 3, 4, 5 and over 1. If I want to plot the next point, I'm going to end up going up 7 and over 1 and up 9 and over 1. And the same thing works on the other side. So this is not a line, because a line, those numbers would be the same, right? I'd always be going up 1 and over 1 or up 3 and over 1. Not the case here with the parabola. I'm going up 1 and over 1, then up 3, and then up 5. It turns out if that a value is not 1, it actually does work similarly, except that you're going to be going multiples of that. So if the a value is 2, you go up 2, and then 6, and then 10, and so forth. So it's just a little trick. Don't worry if you say I'd like to graph it the old way by plotting points. You can certainly do that. But it's just sort of an interesting thing to take a look at. All right, let's do one more, and then we'll make a second video with the second part of this so that it doesn't get too long. This says first find the vertex and then graph. Now, I wanted to put this one in here because look at the last one. The last one was x squared minus 2. This is not x squared minus 2. This is negative x minus 2 squared. A little bit different location of the square in the parentheses, and of course with the negative on the outside, that's going to make a difference. So how do I expand this first? Let's expand x minus 2 squared first. So first term squared, double the insides, last term squared, and then we apply that negative. So I get f of x equals negative x squared plus 4x minus 4. Now, this is a little different, right? We haven't had an a value of negative 1 yet. So a is negative 1, b is 4. We're told that the x-coordinate of the vertex is negative b over 2a. So negative 4 over 2a gives me an x-coordinate of 2. what's my y-coordinate then? My y-coordinate is going to be the opposite of 2 squared plus 4 times 2 minus 4. So 2 squared is 4, so I get a negative 4 plus 8 minus 4, which is just 0. So it turns out that the vertex is at 2, 0. There's 2, 0. Let's plot some points on either side. So now that we know where the vertex is, we can pick a couple of other points. So let's pick 0, 1, 2, 3, 4. Notice that I chose it so that the vertex was in the middle, so that I would get a couple of points on one side and a couple of points on the other side. Now, you can actually go back to the original function to substitute these things in also. So I can go back here and say f of 0 is the opposite of 0 minus 2 squared, which is negative 4, right? Negative 2 squared is 4. The opposite of that, negative 4. If I put in a 1 there, f of 1 is the opposite of 1 minus 2 squared. 1 minus 2 is negative 1. Square it, I get 1. Apply that negative sign, I get negative 1. Now, the nice thing about choosing the points on either side is that when you go to do the 2 on the other side of the vertex, they're going to be identical. So you'll get another negative 1 and another negative 4. So it goes through 0, negative 4. It goes through 1, negative 1, 2, 0, 3, negative 1, 4, negative 4. Right? It's not quite that vertical at the end there. There we are. All right, so there's my parabola. So this thing has an axis of symmetry that comes down here. Right? The axis of symmetry for this graph is x equals 2. So on either side of x equals 2, that graph is identical. All right, so we'll stop this one here. We'll pick up another one for the second part of 11.1.